Have you ever looked up at a bird sitting peacefully on a high-voltage power line and wondered, how is that little thing not getting fried right now? It is one of those everyday sights that we get so used to that we stop questioning it. But once you realize that many of those power lines carry hundreds of thousands of volts, enough to create sparks that can melt metal, the whole situation becomes almost surreal. A tiny bird, lighter than a deck of cards, calmly balancing on a line that could instantly kill a human being if touched in the wrong way. And then, on the flip side, you sometimes hear about birds getting electrocuted or see a puff of feathers under a power pole. So what exactly is happening? Are birds somehow immune to electricity? Do they have super insulating feathers? Or is there something much deeper hiding in the physics of electricity? To understand the real answer, you first have to grasp one fundamental rule of electricity. Electric current flows only when there is a difference in electrical potential. Think of voltage like water pressure. Water does not flow unless there is a pressure difference pushing it. Electricity behaves the same way. It does not randomly jump into objects or bodies simply because they exist near a power source. It only moves when it finds a path from a point with higher electrical potential to a point with lower electrical potential. This simple concept is the key that unlocks the entire mystery of birds surviving on power lines. When a bird lands on a single power line, both of its feet sit at the exact same electrical potential. If the wire is carrying 50,000 volts, the bird ends up floating at that same 50,000 volts everywhere on its body. Its left foot, right foot, feathers, and beak are all at identical voltage. There is no difference between any two points on its body, and because there is no difference, there is no current flowing through it. No current means no electrocution. This is the part that feels counterintuitive. Being at a high voltage is not automatically dangerous. What is dangerous is the difference in voltage across your body. Electricity kills because it flows through you, not because of the number printed on the voltmeter. Think about the pressure in an airplane cabin. The air pressure outside at cruising altitude is extremely low, but inside the cabin everything is balanced. You do not explode because the pressure around your body is uniform. Problems only occur when that pressure suddenly changes at different points on your body at the same time. With electricity, the same idea applies. Uniform potential equals safety. So then, why do birds sometimes get electrocuted? The danger shows up when a bird accidentally creates a pathway between two different electrical potentials. Imagine a bird stretching its wings and touching two wires at the same time. One wire is at 50,000 volts, and the other is at a different voltage, maybe grounded or at 0 volts. Suddenly, the bird's wings form the bridge between two different electrical worlds. Electricity loves taking the path with a voltage difference, and that path becomes the bird's body. The resulting current is more than enough to cause instant fatal damage. Another situation occurs when a bird lands on a wire but also touches a grounded metal component, like the metal frame of a transformer or the steel arm of a utility pole. The wire is at high voltage, and the metal structure is at ground potential. The bird becomes the perfect connector between high and low, and electricity flows through it without hesitation. Larger birds such as eagles, hawks, and owls are especially vulnerable because their wingspans are wide enough to unintentionally touch multiple points at once. Their size increases the chance of bridging to voltages. Now, what about humans? Why can't we do what birds do? Interestingly, humans can touch a power line safely under very specific conditions. Power line technicians in the United States and Canada sometimes work directly on live high-voltage lines while suspended from helicopters. They extend a metal wand toward the line. A spark jumps across, and that spark is the moment the worker and the helicopter equalize to the same voltage as the wire. Once their entire bodies are at the same electrical potential, They can touch the line safely without current flowing through them. The absolute must-follow rule is that they can touch only the wire. If they touch any grounded object or anything at a different voltage, they would instantly become a pathway for electricity. The reason ordinary people cannot replicate this is simple. We are almost always connected to the ground, and electricity always wants a path to the lowest potential. Power companies in North America put significant effort into protecting birds, not only for environmental reasons, but also because bird electrocutions can trigger major power outages, equipment failures, and even wildfires. To reduce accidents, utilities install insulating covers over dangerous hardware, spread wires farther apart to prevent large birds from contacting two at once, and set up special perching devices that encourage birds to land in safer places. Many power companies add reflective markers to help birds see the wires more clearly, especially in low visibility conditions. Modern grids even use sensors and cameras that detect wildlife-related faults, allowing quick repairs and targeted improvements to protect both birds and infrastructure. If you want to understand the physics even deeper, remember that electricity requires three components to flow: a voltage difference, a conductive path, and a closed circuit. A bird sitting on a single wire does not fulfill these conditions. The wire itself is a much better conductor than a living organism, so electricity naturally chooses the better path. Think of it like a smooth highway and a muddy dirt road. If you are driving and both options lead to the same destination, which one do you choose? Electricity will always choose the smoother path with lower resistance, which is the metal wire. And here is the most surprising part of all. Birds sitting on power lines are actually at high voltage. Their entire bodies may be sitting at tens of thousands of volts relative to the Earth. But this does not harm them because all parts of their bodies share that exact same voltage. There is no internal difference to force current through their tissues. Electrocution is always about current flow from one point to another, not about being at a high number on a voltage scale. So next time you see a bird perched calmly on a power line, remember that it is not immune to electricity, and it is not protected by special feathers or hidden biological powers. It is safe simply because it is touching a single point in the electrical system. The moment it touches a second point at a different potential, everything changes instantly. Birds survive because they unknowingly obey the strict rules of physics. One mistake, one extra contact point, and the laws of electricity react with total indifference. That is the strange blend of elegance and danger that defines the natural world.